my name is Aditya and today we will be designing TinyURL. TinyURL is a service which allows users to give a bigger URL and have it converted into a smaller URL that they can use to share with their friends, post on social media, etc. So before we get started, let's first look at some of the use cases for our service, TinyURL. So the first thing we want in the service is for users to be able to give us a big URL and get an output of a shorter URL. So we can say big URL to short URL. The second feature would be that when we're given the short URL or whenever it's queried, that URL redirects to the original URL. So for example, if we had tinyurl.com/xyz, and if this pointed to google.com, once a user queries for this URL, we need to redirect them to www.google.com. The third feature that we want is users should be able to specify their own custom URL. So as an example, users should be able to say tinyurl.com/Aditya should point to, let's say, youtube.com. So here's some of the main use cases for our service. We can also consider adding, for example, usage data, meaning how many times our TinyURL was accessed. We can also consider adding expiration, meaning if we have a tinyurl .com/xyz and it points to google.com, after a certain period of time, that URL expires and it's free to be used again. So let's see how we can think about approaching the system. So the first requirement that we have is whenever a user gives us a big URL, we want to be able to generate a short URL. So one approach to this would be let's consider all our short URLs to be of size. So a short URL to be of size 8 for 8 characters. So we can have A to Z, that's lowercase, so we would have 26 lowercase letters. We can have capital A to Z, which would be an additional 26. Then after that, we can also consider numbers. So we have 0 through 9, 0 through 9 meaning digits. So you have 26, 26, and this is 10. So this would be 26 plus 26, which is 52 plus 62. So we have 62 choices for each of the eight spots. So we can generate 62 to the 8th number of URLs. So let's have this as our starting point. So let's have this as a starting point where whenever we are asked for whenever a user queries a big URL, we want to generate a random string and give that random string back to the user as the short URL of that bigger URL. So there are some potential downfalls to this approach. One potential downfall is when if our system is having a lot of users concurrently querying our service to generate small URLs, what could happen is we return the same short URL for the same big URL. So we could have, for example, we could have user one, essentially user one query. We can have, let's say this is user one. User one queries our service, our system. So this is our system. So we have use cases here. We have the big to small, right? And then we have big to small. We have another use case where we go from small to big. So we can say small to redirect, or we can call it redirection. So these are our redirection. And then we can also have within big to small, we can say that custom is a subset of this capability. So we can say this is a subset. Oh, this is custom URL. It's custom URL. So this points, this is custom. So a user can do this, a user can do this. So back to the point, what I was making was that when there's two users, for example, that two users that query for they both have different URLs and they both query the service to go from big to small. Based on our approach at the moment, we could potentially return the same 8-character bit string back to the user as, oh, this is your tiny URL for your big URL. So one way to address this issue would be we can have it so that every time there's a request to get a smaller URL, all the other requests are queued up. So the one approach would be to have it so that all requests get queued up in some sort of message in a messaging queue, or we could have a locking mechanism on the database or our data store where only after one request is served, another one gets served. So those are two approaches we could consider. So that's one potential issue with our system. The other potential issue is that when we have it's the same, two different people could query for the same. Two different people could query for the same big URL. So for example, two people could say, I want a shorter version of google.com, for example. And if we've already done it once. So it depends on which approach we want to take. One approach could be we have redundancy in our system in the sense that if two people query for google.com, both two different short URLs are generated for google.com. Or the other approach could be that when a user asks for a big URL when a user asks for a short URL and the big URL is already present within our data store, we just return the small one. So we could potentially be returning the same short URL to multiple people. So depending on which use case we want for the system, we can make that choice. So we have that. So let's consider, so we have, we've talked about going from big to short. We've talked about how we want to redirect from a short URL to the original URL. So in our database or in our data store, we can have something of a key value pair. So we have something like this where we have, like, let's see, this is our data store. We have our key would be the big URL. So this could be big URL. our value would be a short URL, right? So this would be our store. So this would be one store storing from a key, or we can do it the other way actually. Let's do it the other way, short to big. So we can say, we will go, key is short, and value is the big one, big URL. Okay, so we have that. We also have to talk about how we would be generating these. One approach would just be to have it just going sequentially. So we would have just like starting from, so we have 62 raised to the 8. We can map each number with one permutation of this 8-character string, and have that as our way of giving out short URLs. Another approach could be randomly picking one. But that comes with the downside of having to make sure we don't return one that's being used for a different URL. So we would have to consider that. In our key store as well, so going from, in addition, so we've touched point number 1, use case 1, use case 2. To allow custom ones, that we can reject if we can force users to only have an 8-digit unique 8-character short URL that hasn't already been used. So if a user tries to use that as their short URL, but it's already in use, we would reject it and ask the user to resubmit their request. So that's one approach. And if we do go with that approach, doing it sequentially or giving out different different short URLs in a sequential manner, going from like just A to like A empty to B A B A all the way down. That could conflict with if we allow users to make their own custom URL. So we have that. We can also, so we touched upon potential ways to make a short URL, how we're going to be storing it. Some of the issues I talked about in terms of having multiple people asking for the same, or multiple people getting the same short URL back, which is what we don't want. Another use case we have is expiration. So allowing users to input expiration, or having a default expiration as well. And we would want to have a default expiration if the use of our system it's being used a lot. So we want URLs that are like past a certain like time to live. They get evicted from our store. We can also, so in our picture, we can also think about putting a cache in front of our data store. So especially for URLs that are, or short URLs that are, for example, might be shared on social media, like on someone's Facebook or on Twitter, where it's causing like a lot of traffic. So those short URLs are going to be accessed a lot. So we should consider adding a cache as well to speed up our service.